Assalamualaikum and very good day to all of you. My name is SYUHADAH binti NOORDIN and my matric number is 189873. Today in this video I would like to share the research finding that I have done for my final year project with the title is removal ammonia and phosphorus from synthetic wastewater by struvite crystallization and enhance it using coagulant. Okay, let's start. So, the outline of this presentation is introduction, problem statement, objective, methodology, result and discussion, conclusion, and also recommendation. Now, let's move on to the next slide, which is introduction. So, what is struvite crystallization? Struvite crystallization or precipitation is newly developed technique that facilitates the removal of ammonia and phosphorus from wastewater by converting those components into struvite crystal. So, this crystal can be formed following this chemical reaction: magnesium ion, ammonium ion, phosphate ion together with the 6 molecules of water to form magnesium ammonium phosphate, or also known as a struvite crystal. The enhancement of struvite fine particle also can be done by using Chitosan. It is because of Chitosan is a positively charged molecule that make the particle aggregate through the collision and the particle bridging, which later make the particle more stable and easy to harvest. Next, move on to the problem statement. According to the Food and Agriculture Organization of the United Nations, world population expected to reach 9 billion by 2050, which more phosphorus need to be supplied because the global middle class was also increasing, which need more meat and dairy to be consumed. However, according to the Cordell, all reserve phosphate rock will be exhausted or diminished within the 50 to 100 years. Not only that, a high amount of ammonia and phosphorus in wastewater has led to eutrophication. It will become a possible threat to human, animal, and especially for the aquatic life if that wastewater is not discharged properly. So, how are we going to solve this problem? Don't worry, because the problem is solved. Because struvite nowadays has become a promising technique to recover phosphorus and ammonia from wastewater. So moving on to the next slide is about the objective of this study. I have 3 objectives. First, to investigate the role of operating parameters such as the pH and the molar ratio of magnesium, ammonia, and phosphate by increasing the magnesium concentration. Second, to study the coagulation process on cell ability by using Chitosan in enhance the struvite precipitation. And third is to characterization the struvite formation with and without Chitosan and pentonine. So, for the methodology part, it was done by prepare the synthetic wastewater first, and then it will divide to 2 parts of experiment, which is the first part I will study about the pH and the molar ratio, and the second part will study about the Chitosan and pentonine. And from these 2 parts, the best result will submit to SEM-EDX and SRD analysis. All the experiment will set up under the jar test with the 6 pedal, and this is how the jar test look like and set up. And this is the schematic diagram of the jar test with the 0.5 liter beaker under the jar test. For the beaker, the solution depth is 6.5 cm and the radius of the beaker is 10 cm and the depth of the paddle into the solution is 12 cm. Proceed on the next slide, which is result and discussion. So the first result is effect of the pH that was studied at pH 7, 8 and 9 with the molar ratio is equal to 111. So as you can see from the graph, as the pH increased from pH 7 to 9, the removal efficiency also will increase, which gives the highest recovery efficiency for both components is at pH 9. Therefore, the optimum pH was found to be at pH 9. This is similar to what Licori has stated in their study that pH 9 is the optimum pH for struvite crystallization. Next, the effect of molar ratio was studied at pH 9. Since the molar ratio of magnesium to ammonia and phosphorus play an important role, so the molar concentration was varying in the synthetic wastewater from 0.2 until 0.8. Thus, the molar ratio of magnesium, ammonia and phosphate is equal to 111 until 411. So, as you can see from the graph, when the molar ratio increase, the recovery of ammonia and phosphorus also increase. But ammonia recovery remain constant or stable at the molar ratio is 311 and 411. This is because the high amount of magnesium ion will easily form magnesium hydroxide and magnesium phosphate under alkaline condition, which eventually will cause the depletion of ammonia removal. Opposite to the phosphate recovery or phosphorus recovery, it remained constant at 111 until 211 but increased from 211 until 411. So, this result is in agreement with Darwish, Decory, and Liu that reported by increasing the magnesium concentration will increase the struvite formation. Next, the effect of Chitosan as a coagulant on struvite formation was studied by varying the dosage of Chitosan from 200 to 800 mg per liter at optimum condition. So, from the graph, no significant difference was shown for ammonia recovery, but for the phosphorus removal, it increased when the dosage increased from 200 to 400 mg per liter, but decreased from 400 to 600 mg per liter and remained constant after that. This is because when we increase the dosage of Chitosan, it will strengthen the Chitosan ability to attract more impurities in the wastewater. So, it will decrease the efficiency of recovery. Not only that, Chitosan has long chain polymer with the positive charge that effectively coagulate the negatively charged particle like phosphate instead of negative charged ammonium ion. Next, the effect of using bentonite as a coagulant aid. Even though Chitosan can enhance the struvite formation, however, it works well when the right combination of bentonite were used. Therefore, the effect of mixture ratio of Chitosan was studied at 1:5 to 4:33, 4:3, and 5:1 under the optimum condition. So from the graph, the ammonia recovery slightly decreased, or actually there is no significant difference. However, the phosphorus removal was remain steady at the beginning, but start to decrease when the molar ratio of Chitosan and bentonite changed from 2 to 4 until 5 to 1. This is because when we overdosing the Chitosan, it will destroy the polymer and the particle bridging. Therefore, it will lead to a decrease in removal efficiency. Next slide is about the comparison ammonia and phosphorus recovery on struvite with and without coagulant. So as you can see from the bar chart, there is no significant difference when we adding the Chitosan and bentonite and without we adding the coagulant. This is because the use of coagulant is to enhance the struvite fine particle to settle down rapidly, not to increase the recovery of ammonia and phosphorus in the wastewater. However, when the struvite with the Chitosan and struvite with Chitosan and bentonite, as you can see, the phosphorus recovery is slightly increased. So it can prove that Chitosan works better with the bentonite as a coagulant aid. So as you can see, there are three different pictures. A is struvite with the coagulant, B is struvite with the Chitosan, C is struvite with Chitosan and bentonite. As you can see, the struvite with the addition of Chitosan and bentonite have the larger and heavier flock will form, and the particle will settle down rapidly and shortly after the mixture stops. Therefore, it could decrease the potential of fine particles from being washed away during the harvest process. So, this is dry struvite that were obtained. A is struvite at optimum condition, B is the struvite with chitosan, and C is struvite with chitosan and pentonine. As you can see, the struvite is in powder form. So proceed on the characterization part. As I mentioned earlier, the best struvite formation will submit to analysis. So this is how struvite at pH 9 with the molar ratio is 411 under the SEM with the modification is at 500. You can clearly be seen that the size of precipitate crystal was irregular. So next, this is the EDX result. The struvite with chitosan and without chitosan. So as you can see, the elemental composition of phosphorus and magnesium for struvite with coagulant slightly higher than without coagulant. This one. So next is the result for SRD analysis. The struvite precipitation without chitosan show that the highest peak is matched with the struvite database. However, the highest peak struvite with the chitosan and pentonine show it is new bright. This is because, like I mentioned earlier, the EDX analysis showed that the struvite with coagulant contain high amount of O, P, and magnesium compared to struvite without coagulant. So I can say that the addition of chitosan and pentonine will not affect the purity of struvite. So, for the conclusion, in this study, it can be concluded that the formation of struvite crystal is highly dependent on pH and molar ratio of magnesium, ammonia, and phosphorus. Besides, the effectiveness of Chitosan and pentonine as a natural coagulant in improving struvite formation was also achieved. It is because it managed to agglomerate the struvite fine particle to settle down rapidly and shortly. In the end, the struvite formation and the derivatives still can be used as phosphorus source to replace the use of rock phosphate. Not only that, it also beneficial for aquatic ecosystem as well as for agricultural production. Lastly, for the recommendation, I suggest for the further research to use closed reactor instead of open jar test because it's good to avoid the ammonia stripping and easy to control the pH of the solution instead of manually adjust the pH. Next is to observe the effectiveness of chitosan as a natural coagulant on struvite formation with different type of wastewater. Lastly is to test the effectiveness struvite as a slow release fertilizer by applying on various type of plants and compare with the NPK fertilizer. That's all for me. Thank you for listening.